All right, Math 1, Unit 6 practice test solutions. All right, 1 through 3, use the histogram. So how many students are shorter than 70 inches? Well, all these students over here are 70 inches or taller, so we count these 3 bars, which is 6 plus 4 plus 5, or 15. How many students are taller than 64 inches? Well, again, 64. So here's 64. So it's the 3 to the right, which would be 6 plus 2 is 8 plus 1 is 9. All right, number 3. Are there an equal number of students who are less than 65 inches and taller than 69? So here are the less than 65 inches. That's 5 plus 4 is 9. And the greater than 69 inches would be 3. So that is a no. And again, those are most likely to be multiple choice questions. All right. So this is a actually really easy question. I'm sure it's going to be on there. It's very wordy. A former professional golfer is a teacher of a golf class. There are 10 golfers taking the class. At the end of the 6-week class, everyone, including the teacher, plays an 18-hole round of golf. His score is 30 strokes less than the best golfer in the class. Which measure of central tendency is the most affected by the inclusion of the teacher's score? Well, the teacher's score is an outlier. It's a lot different from all the other scores, so the mean would be the most affected. Let me give you a little example of why. Let's say there are 3 players. I don't know. Let's just make up some numbers. Let's go 19, 20, and 21. Those are the scores of the 3 players. If we average these 3 players, okay, their score, the average or mean, is 20, okay, and the median is 20. Does that make sense? 19 plus 20 plus 21 divided by 3 is 20, and the middle number is 20, right? Well, let's just say we add a score of somebody got a 1. Okay, and now we have to add 4 together. And let me get my calculator on here. So now, instead of, what I can do is put it here. So now it's 1 plus 19 plus 20 plus 21 divided by 4. And the mean now with this guy is 15.25. And what's the median? Well, the median is the average of these two, which is 19.5. So you can see the median changed very little bit with this outlier, but the mean changed quite a bit, didn't it? So you can see the mean is the most affected when you include an outlier. Are you following me here? Okay. So the median didn't change very much with the outlier, but the mean changed a great deal. All right, moving on. These 2 questions I'd be willing to bet that are going to be on your test. What is the percentage of values? What percentage of values are between 50 and 80? 50 and 80, that's the box here. That's the interquartile range, the IQR. And as I've said it several times, the interquartile range has 50% of your data. Okay, what is the IQR? What is the interquartile range? Well, the IQR is the difference between the 3rd quartile and the 1st quartile. So 80 minus 50, or 30. The interquartile range is 30. Okay? Any questions on those 2? All right, let's move on. All right. What type of correlation is represented by the data in the following scatter plot? All right, so we can see there's a pretty strong correlation right here, and that is a positive correlation, abbreviated by POSCOR, and this is a pretty strong negative correlation. Okay, and which correlation coefficient is the most accurate for a trend line for the scatter plot in problem 8? This one right here. Well, we know it's negative, and it's a very strong correlation, so it's going to be something close to -1, which looks like it is C would be the best choice there.
So how do you know if it's 0.07?
Okay, so all they're trying to get you, first of all, is to understand negative or positive, so you guys understand it's a negative. So we're just trying to get you to judge between a weak correlation and a strong correlation. Okay, this is a very strong correlation. A weak correlation would have all kinds of points out here like this. Okay, something like this, you might not even think there's a correlation here, but there actually is a correlation, but it's a weak correlation. So this would be, if you had all these dots on it, then it would be a -0.7. Okay, so you're really just judging, when you look at the correlation on the test, is it a strong correlation or a weak correlation? Strong correlation, get it really close to positive or -1. If it's a weak correlation, you want it closer to negative or positive 0. Well, closer to 0, I should say. There's no negative or positive 0. Okay? All right. Moving on to two-way frequency tables. Use the two-way frequency table for problems 10 through 12. Round to the nearest hundred. C will usually tell you when appropriate. Okay, what is the marginal frequency of total students who prefer sports car? Remember, marginal is on the edge, the outside, and you notice there's no relative there, so all we should have is a number. The marginal frequency of students who prefer sports cars, right here, 84. Just 84. Okay? Number 11, what is the joint relative frequency of males who prefer SUVs? So here's the males who prefer SUVs, 21. But since we have that word relative, it's 21 out of 240. So your test is going to be looking for decimals. So it will be 21 divided by 240, which is 0.087. We round to the nearest hundredths, so it's 0.9. 0.09. So 9% basically. Okay? Number 12, what is the conditional relative frequency that a student is female, given that, remember I always said given that is the division bar, the student prefers sports cars. So numerator divided by denominator. So conditional means one row. So we're talking sports cars, so we're talking this row right here. So it is going to be 45 divided by 84. So 45 divided by 84 is 0.535. So it's going to be 0.54 or 54%. Questions on 10, 11, 12? Okay, let's move on. For the following situation, determine if there is a positive or negative correlation. If there is a correlation, is it a causal relationship? Have we talked much about causal yet?
No.
Okay, causal means one causes the other. Remember, the x-axis is your independent variable. The y value is your dependent variable. And what we're saying is x causing y to get bigger or smaller? For instance, number 13, the number of hours spent studying and the score on your test. Now, you guys may not want to believe it, but I think you would have to agree that the more you study for a test, the higher your score. You guys may not want to believe it, but it's true. So the more you study, the higher your score. So there is a positive correlation here, right? Correlation. 2 L's, 1 L. I think 1 L. Positive correlation. Okay? There is a positive correlation between how much you study and how well you do on your test. And there is causation. Your studying is causing you to get a better grade, right? The more you study, the better you'll do. So the studying causes you to get a better grade. All right? Let's look at number 14. The number of center hits in a dart game and the distance from the board. All right, so let's think about this. Down here we have distance, and here we have center hits. So I think we would agree that if you were 1 foot away from the dartboard, you could reach out and put that dart right in the center. So you'd get 10 out of 10 here, right? But as you move further away, out here at 10 feet, now you're going to have a lot less center hits, right? So the further you are from the dartboard, the harder it is to get a center hit. So that would be an example of negative correlation. And it is causal, right? There's a causal relationship. The further you get from the dartboard, the harder it is to hit center. So the distance is causing you to do worse, isn't it? So there's a causal relationship. Okay. Number 15, the number of letters in the city you live in and the average annual rainfall. There's no correlation, is there? Definitely no correlation. No correlation. Okay, so let's talk about causal relationships for a minute. All right. So let's talk about the population and mailboxes. Okay. So our x-axis is the population. The y-axis is the number of mailboxes in your city. All right? I think you guys could see how as the population of a city gets bigger, the number of mailboxes in the city are going to get bigger, right? Because as the population goes up, everybody needs a mailbox. So as the population increases, the number of mailboxes in the city goes up. Does that make sense? So there's a positive correlation, and there is causation. The population is causing there to be more mailboxes in the city, right? Okay, now let's reverse this. Now, let's say the independent variable is mailboxes. Oops, there should be an E there. And now the y-axis, or the dependent variable, is population. So, as the number of mailboxes increases in the town, does the population go up? Maybe. I mean, maybe they move a mailbox factory into the town, and because the new mailbox factory moved into town, some people move into the town as well to work in the factory, right? But now as they start producing mailboxes, and all of a sudden they produce 1 million mailboxes, do 100,000 people have to move into the city? No. So there might be a correlation, but it's not causal, is it? Every time there's a mailbox built in the factory, somebody doesn't have to move into the town, do they? Oh, we can't build any more mailboxes until somebody moves into our town. No, that's not how it works. So even though there might be a correlation, it doesn't mean that the mailboxes are causing people to move to the city. There's no causal relationship. Okay? All right. We talked a little bit about this, about meta-studies. Meta-studies are where they do surveys and they ask people all kinds of questions, completely unrelated questions, and they find things that are correlated, that are connected. Okay, so a meta-study is simply basically a survey, and they find things where they are related. Okay? And sometimes there are positive or negative correlations, but they have nothing to do with each other. So I offered extra credit to one of my classes, and I'll offer it to you guys. If anybody can find a story, an article in a paper or magazine or something on the internet where there is a relationship, a correlation, but no causation. So here we have uranium stored at a U.S. nuclear power plant. Okay, and wait a minute, who is this one? Is this I thought this was I'm not sure. I don't know about this one. Okay, this is a good one here though. All right, I gotta look at that other one before. I thought we saw that one was actually. So here we go. Let's look at this. So this is the number of people who died by becoming tangled in their bed sheets. Okay?
Wait, is this real?
This is real. These are actual statistics.
You're lying.
No. So this is people who died in their bed sheets and how much cheese they consumed.
What?
Yes. So you can see that there is a positive correlation between how many people died in their bed sheets and how much cheese was consumed. So for some strange reason, I guess when people get killed in their bed sheets, all their mourners go and eat a bunch of cheese.
You're lying.
I don't know. No, there's no correlation, but this is true. Okay, they found this in, in 2000, between 2000 and 2009. These are the number of people who died tangled in their bed sheets, and this is the amount of cheese that was eaten in that same town. So obviously, the more people who die in their bed sheets, the more cheese people eat. So there is a positive correlation. You cannot deny it. But is the deaths causing people to eat cheese? No. So there is a positive correlation, but no causation. Okay? All right, moving on. Okay, let's get going. Number 16. This one's going to be on the test. One just like this. So, the equation models the data of the average height of boys 5 to 13. So remember, we call this y hat. Using the equation, how tall do you estimate an average 12-year-old will be? So let's plug in 12. So it's y equals 2.3 times 12 plus 33. So we go like this, and we go, can you see that? 2.3 times 12 plus 33. So it is our guess that a 12-year-old will be 60.6 inches. Okay, don't worry about number 17. We took that one off the test. Let's move on. All right. 8 students took an extra credit quiz for their history class. The table shows the scores of the students. So let's order them first. So let's see. Tom got a 1. Oh, poor Tom. Bill got a 7. Not bad. 1, 2, 3 people got 8s. And what do we got? 2 people got 9s. And Bob got a 10, messing up the curve. Okay. So we put them in order. Now we're going to construct a line plot. So look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We usually give you a number line that'll fit all the possible data. So 1, I just put an X here. 7, 3 8s, and 2 9s, and 1 10. All right. So mean, median, and mode. So mean, we have to add them all together. So 1 plus 7 plus 8 plus 8 plus 8 plus 9 plus 9 plus 10. So make sure I got them all on there. I can actually go back. I got the 1 on there. I know I got the 1. And this little extra effort is worth it if you're taking a test, I would think. So 1 plus the 7, 3 8s, 2 9s, and a 10. Perfect. So add those all up, and I get 60. Okay, and then 60 divided by 1, 2, 3, 4, 5, 6, 7, 8. So 60 divided by 8 is 7.5. So my mean is 7.5. The median, pretty easy, just count. 1, 2, 3, 4, 5, 6, 7, 8. So we have to average 4 and 5. So 1, 2, 3, 4, 5. So 8 plus 8 divided by 2 is just 8. So my median is 8. My mode is the one that happens most often, 8. And my range is 10 minus 1 or 9. Questions on number 19? Okay, moving on. Which measure of central tendency best describes the data and why? This is going to be the median. The median, because 1 is an outlier. Outlier. Guys, whenever there is an outlier, it is the median. Trust me, they're going to ask you that on the test. Okay, moving on. Okay, South High Drama Club sold a combined 435 tickets. I'm going to put that right there. To the matinee and evening performances of their play. Of the 186 tickets sold for matinee, so we can put 186 here, 74 were to adults. Of the 249 tickets sold for the evening show, 191 were students. Okay? So, use the information to construct a two-way frequency table. So it's pretty easy, guys. We're going to go 186 minus 74 to find out how many students went into the matinee. 112. And then over here, we have 249 minus 191 equals 58. So 58 adults went to the evening show. And then to find the total adults, we should go 74 plus 58, which is 132. And we should add up 112 plus 191 and get 303. Now, we should check all of our numbers, guys, if it's worth it to you to do well on a test. 74 plus 58. 74 plus 58 plus 112 plus 191 should add up to 435. 186 plus 249 should add up to 435. And 5, 3, 4, these two should add up to 435. So I checked all my possibilities. It all looks pretty good. Any questions on that? Okay. All right, moving on. Number 25, complete the table. So we did this already, so we're going to take this equation, we're going to plug in the x value, and we're going to get a predicted value. And then the residual is the actual value minus the predicted value. Okay? So let's run through this real quick. I'm not going to show you all these, but we've got negative 0.3 times 2 plus 8.7, and we get 8.1. All right, then 6 minus 8.1 is negative 2.1. Okay, we're plugging in 4, so that's negative 0.3 times 4 plus 8.7 equals 7.5. And then 16 minus 7.5 is positive 8.5. Now plugging in 6. Negative 0.3 times 6 plus 8.7 is 6.9. 27 minus 6.9 is 20.1. And finally, negative 0.3 times 8 plus 8.7 is 6.3. And 24 minus 6.3 is 17.7. Questions on that? All right, now, the question on the test is a little wordier than this, but it basically says, hey, here is your line of best fit, the equation for your line of best fit. We want you to plug in some value for x and get the predicted amount like we did right here. And then it's going to say the actual amount when x equals whatever we said is here. You simply find the predicted amount and then subtract the actual amount, or subtract the predicted amount from the actual amount to get your residual. Questions? Okay, let's move on then. All right, 26 through 30. Use the table to answer question 26 through 30. Make a scatter plot of the data. So 1 and 30. So it looks like we'll go 10, 20, 30. And 2 and 55. So 10, 20, 30, 40, 55. 3 and 80. So 10, 20, 30, 40, 50, 60, 70, 80. 4 and 112. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 110, 112, about there. And then 5, 136, 1, 2, 3, 4, 5. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 30. 36 would be about right there. Okay, draw the line of best fit for the data. So you are going to have to draw a line of best fit. So if you want during the test, I'll give you a straight edge. So just those are all pretty good there. So I'm going to go right about there. Okay. Let's see. Write an equation for the line of best fit using the following points. So 2, don't look at your line, look over here. 255 and 5, 136. So remember, the first thing you have to do is find the slope. So it's y2 minus y1 over x2 minus x1, or 136 minus 55 over 5 minus 2. So 136 minus 55 is 81 over 3. And then if we take 81 and we divide it by 3, we get 27. So our slope equals 27. So now we use the point slope formula. Y minus y1 equals m times x minus x1. And we plug in y minus, where is y1? 55 equals our slope, which is 27, times x minus 2. Does everybody understand how I got that plugged in? Okay, then we have y minus 55 equals 27x minus 54. Then we're going to add 55 to both sides, and I hope you can see. I'm going to write it. I wrote it a little too big. It's y equals 27x plus 1 is our line of best fit. Does the data show positive, negative, or no correlation? Positive correlation, a very strong positive correlation. How long would you expect an 8-month panda to be? So we simply plug 8 in for x. So y equals 27 times 8 plus 1. So 27 times 8 plus 1 is 217. So we would expect the panda at 8 months old to be 217 inches long. Any questions there? Okay, this question is exactly how it's going to appear on the test. Okay? So the linear regression equation for the data is y hat equals negative 2.4x plus 16.5. Find the predicted value when x equals 6. That means plug in 6 for x. Okay, when I plug that in, I get negative 2.4 times 6 plus 16.5. And I get negative 12.8.
Wait, no, that's wrong. You can plug in this.
Let me see, because I didn't think that. Let's see, negative 2.4.
You didn't put the 6.
I didn't? Times 6 plus 16.5 is 2.1. Good job. Positive 2.1. Thank you. Positive 2.1. That's the predicted value when x equals 6. Now here what they're telling you is, hey, find the residual y minus y hat at x equals 6 if the actual value is 3. So the actual value is 6, 3, but our predicted value is 6, 2.1. So we have to go 3 minus 2.1, which is 0.9. Do you understand that? That question just like that is on the test. Does everybody understand that?
Wait, so you just.
We plugged in 6 into this equation to find the predicted value. And then it tells you when x is 6, the actual data is 3. So we simply went 3 minus 2.1 to get 0.9. This question's on the test. Okay? I think that's it.